Looking at exercise 7F, logarithmic graphs and exponential functions. Now we're comparing the graphs of y equals 2 to the power of x. Now that's an exponential graph. We've actually done those types of graphs in our functions topic. Okay, so if you had to look at the red or the blue graph, say just here, which one would you think is 2 to the power of x? Anyone? The red or the blue one? It is the red one. It's the red one. So the exponential functions go like that. You might want to put arrows on the ends of them as well. But let's have a look. So just doing up a quick table of values for y equals 2 to the power of x. When x is -2, that's 2 to the power of -2 is 1 over 2 squared. No, it's a quarter. Okay, good. 2 to the -1, when x is 1, that's 1 over 2 to the 1, which is a half. 2 to the power of 0 is 1, 2 to the power of 1 is 2, and 2 to the power of 2 is 4. Now, if we were to come down and sketch that graph, so -2 a quarter, etc., we would find that it's this graph. So I've got -2 a quarter, -1 a half. When x is 0, y is 1. When x is 1, y is 2. And when x is 2, y is 4. We have seen exponential graphs earlier in the year. You may want to label that graph as y equals 2 to the power of x. Okay, so let's just look at what we think the domain is. Just going back with domain and range, remember earlier in the year, what would be the domain of that? What x values are allowed? So let's look at the x-axis. It appears that, are there any values of x that you can't have? No. So it would be what? All real x. Well, what about the range? So looking at the red graph, all the y values are greater than 0. Now, which axis is an asymptote? So we've got yes, so the x-axis, it's actually the negative x-axis, but that's fine. The x-axis is a horizontal asymptote. So the x-axis is a horizontal asymptote. As x approaches, so this is for the, actually I wanted, yeah, as x approaches, so with the asymptote, as x approaches what? No, negative infinity. So as x gets as x approaches negative infinity, we'll just do this one first. Y approaches. So as x gets really large in the negative direction, what happens to the value of y? It gets closer and closer to 0. Yeah. I know on the other end anyway, as x approaches positive infinity, I need to zoom out a bit. So as x gets very big in the negative direction, so as x approaches negative infinity, y approaches 0. So I'm just doing this one for the asymptote bit, okay? And the graph is concave. Oh, have we done that? Yes, we have. Well, you sort of have in parabolas, yeah. So let's look at the graph of y equals log to the base 2 of x. Now, let's just do these ones first. So we say 2 to the power of what gives me 1? 0. We've got 2 to the power of what is 1. So when x is 1. So log to the base 2 of 1, 2 to the power of 0 gives me 1. So if x was 2, 2 to the power of what gives me 2? 2 to the 1. If x was 4, 2 to the power of what gives me 4? 2 squared. Okay, now, 2 to the power of what gives me a half? We can script. So 2 to the power of something is a half. Now, a half is 2 to the -1. So it must be -1. And 2 to the power of what is a quarter? Now, a quarter is 1 over 2 squared, or 2 to the -2. So 2 to the power of -2 gives me a quarter. Okay, so if we were to sketch those, so we need a quarter -2, a half -1. So we've got a quarter -2. Please put the points on your graph. A half -1. 1, 0. 2, 1. And 4, 2. Put arrows. You've got to put arrows on the ends of your curve. And this is the graph of y equals log to the base 2 of x. Now, we were working with logs last week. We knew that you can't take the log of a negative number. So if you go to your calculator and you try log of -1, log of negative 0.1. Look at the curve, the graph for y equals log to the base 2 of x. There are no x values that are negative. All right, remember we said if you take the log of a number between 0 and 1, you get a negative answer. And if you do the log of 1, you get 0. So we looked at these things last week. And the log of anything bigger than 1 is a positive answer, like log of 2 is 1, log of 4 is 2, and so on. Okay? I've also got, so let's look here for the log graph. What's the domain? Domain for the log curve. Good. So x is greater than 0. And the range for the log curve. So all real y, that's right. So if we look at the y values, remember range is y values. What y values are allowed? Well, there doesn't seem to be any restriction up and down. All right. So it's all real y. Which axis is an asymptote here? Because it's, yeah, the y-axis is a vertical. So the y-axis is a vertical asymptote. And as x approaches what? I'm just talking about the asymptote here. As x approaches 0, and I'll put from above. So from the positive side. So as x approaches 0 from the positive direction. So from this side, whoops, I'm going to go bigger. Sorry. So as x approaches 0 from the positive direction, y approaches what? Negative, infinity, and the curve again, oh, it's concave, down. Okay, so putting these two side by side, look at these two boxes side by side. They appear to be exact opposites of each other. Well, whatever's happening for x here is happening for y in the other function. Look, the domain is all real x. Over here, the range is all real y. The range is y is greater than 0. Here, the domain is x is greater than 0. So it's like the x's and the y's have been swapped. Let's have a look. Look at the x values here. When x is negative 2, y is a quarter. When x is a quarter, y is negative 2. They're swapped. When x is negative 1, y is a half. When x is a half, y is negative 1. So it's flipped. See? 0, 1, 1, 0. 1, 2, 2, 1, 2, 4, 4, 2. So these curves are reflections of each other in the line. What line do you think this is? Yeah. So now for y equals 2 to the power of x and y equals log to the base 2 of x, okay, they are called inverse functions. So the two graphs are reflections of each other in the diagonal line y equals x. This is because they are inverse functions of each other. So their tables of values are the same except that the x and y values have been swapped. Okay? Now, so therefore, this is just our little rule here. If we've got y equals a to the power of x, its inverse function is y equals log to the base a of x. We've just looked at the example y equals 2 to the power of x and log to the base 2 of x. So I could do the same with 3 to the power of x and log to the base 3 of x. 4 to the power of x, its inverse function is log to the base 4 of x. Okay? If I knew a table of values for one function, I could just swap the x's and the y's and I'd be able to sketch its inverse function. Okay? Looking at these two functions here, see how I've shifted within the bracket? Is this a sideways shift or an up and down shift? Sideways, and then we always shift the opposite of where, you know how it's x minus 1? Which way is this graph shifted, to the left or the right? Yeah, it's shifted 1 unit to the right. But let's just do our table of values anyway. So y equals, these are just the same. We can fill this in later, but 2 to the power of what is a quarter? Anyone? This is the same table. Yep, negative 2. 2 to the negative 1 is a half. 2 to the 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. Fill that in later. All right, that is the graph here. So the blue one is y equals log to the base 2 of x. If we look at those values, we've got a quarter, negative 2. I want you plotting the points on the graph. A half, negative 1. X is 1, y is 0. X is 2, y is 1. X is 4. y is 2. So that is the graph of y equals log to the base 2 of x. Okay, all good? Oh, look, I'll just do the domain. Oh, no, domain is x greater than 0, range, or real y. And we know which, no, it's not, the y-axis is the vertical asymptote. And we know as x approaches 0 from above, y approaches negative infinity with that one. That's what we looked at before. Now we're going to look at log to the base 2 of x minus 1. So I've changed my values here to 1 1/4. Because if I do x is, say, 1/4, I'll end up with a negative. So in this first graph, I substituted when x is 1/4. But if I put 1/4 here, 1/4 minus 1 is negative 3/4. If you do log of any base, even ln, or log to the base 10 of a negative, it's undefined. So this curve here, I can't take the log of a negative number, no matter what the base. Okay? So I've chosen 1 1/4. So when x is 1 1/4, we get 1 1/4 minus 1 is 1/4. It gives us the same result as over here. We good with that? 1 1/4 minus 1 is 1/4. So it's log to the base 2 of 1/4 is negative 2. This will be log to the base 2 of 1 1/2 minus 1 is 1/2. You get negative 1. 2 minus 1 is 1. Log to the base 2 of 1. 2 to the power of 0 is 1. What's the next one? When x is 3. 3 minus 1 is 2. 2 to the power of 1 is 2. When x is 5, 5 minus 1 is 4. 2 to the power of 2 is 4. Okay, so if you were to sketch those, 1 1/4. So put the dots on your graph so that I know that you've... Right, 1 1/2, negative 1, 2, 0, 3, 1, 5, 2. All good? So this one is log to the base 2 of x minus 1. So, shifted 1 unit to the right. What you do, you look at the point. See this point? Shifted 1 across to the right. The 1 has been shifted to 2. This 1 has been... So that's been shifted 1 to the right. This has been shifted 1 across to the right. Okay? So, be careful here with your domain and range. So, domain... X values, girls, be careful. X values only seem to start from here. What have you got? X is, no, not 0 this time. Greater than 1. So this, girls, it looks like you might want to get another color and put a dotted asymptote down here for the graph. So that asymptote's only for my purple graph, or your purple graph. The asymptote is for log to the base 2 of x minus 1. The asymptote is no longer the y-axis. Okay? So we've got the domain will be x is greater than 1. Let me move up here. The domain is x is greater than 1. Okay, the range. Look up and down. Looks okay? Or real y. Now, which line is the asymptote? It's the pink one. What's the equation of this line? No. It's passing through. X is 1. So it's the x equals 1. Oops, sorry. So the line x equals 1, the pink line, is the vertical asymptote this time. So the line x equals 1 is the vertical asymptote. Can we all see? Okay, as x approaches, now we were doing 0 from the right-hand side. Tell me, describe this asymptote. As x gets closer and closer to what? Which value? To 1 from above, y approaches negative infinity. Are we all good? So I'll just zoom down again. So this is the graph of y equals log to the base 2 of x shifted 1 unit, which way? To the right. Now I want you in another color to sketch the graph of y equals log to the base 2 of x minus 2. You can fill out your little table of values and put it in. Here, when x is 2 1/4. 2 1/4 minus 2 is 1/4. So you just look up at the other table, log to the base 2 of 1/4. All good. And then you keep filling your values. 2 to 2 1/2. 2 1/2 minus 2 is 1/2. It's the same as the answer to log to the base 2 of 1/2. 2 to the power of what is 1/2? It's 2 to the power of -1, and so on. 3 minus 2 is 1. Log to the base 2 of 1. 2 to the power of 0 is 1. 4 minus 2 is 2. 2 to the power of 1 is 2. 6 minus 2 is 4. 2 to the power of 2 is 4. Then can you please plot those? And you'll just tell me. I would just like to know what the asymptote is. So the line, whatever, is the vertical asymptote. And just describe it, that this is the graph of what shifted where. Shifted 2 units to the we sketched it. Yep. So it's 2 1/4 would be here. -2. 2 1/2, -1. 3 0. 4 1. 6 2. You might want to do it in pencil because I've got a red pencil. Yeah, always do your curves in pencil. Be careful. And your asymptote, so make sure you're labeling the correct ones. So this one will be log to the base 2 of x minus 1, and my red one is log to the base 2 of x minus 2. Okay, I'll just rub that off. All right, so it's been shifted 2 units to the right. Okay, and what's the asymptote this time? Yeah, the line x equals 2 is your vertical asymptote. Look, can you just grab a pencil? I know I didn't ask you to sketch it, but I think we need to. Y equals log to the base 2 of x plus 1. I want to sketch that one. Where do you think it's going to be moved? It's going to be moved to the left. So let's just look at the blue curve and move everything 1 unit to the left without drawing up a table of values. So just fit it somewhere and with a description. So log to the base 2 of x plus 1 is log to the base 2 of x shifted 1 unit, this time to the left. Now, this is, we okay with that one? Y equals log to the base 2 of x plus 1. I want that one sketched. Just let's not do a table of values this time. Let's just take the original graph and move everything you can see 1 unit to the left. So this point here will move over 1 left. This point here will move over 1 left. Got it? This point here, 1 left. This one here at 1/2 goes to -1/2. And this one here at 1/4 goes to -1/4. Just do it lightly in pencil. Now, this one is interesting because the asymptote is no longer, we've actually cut over the y-axis. Okay, so this one is y equals log to the base 2 of x plus 1. So I shouldn't have labelled them all there on the graph. This one is log to the base 2 of x. Now, it's shifted 1 unit to the left, but I just want to know if you can just tell me what the vertical asymptote is for that one. That's right. Vertical asymptote is x is -1 for that one. So, yes, we've got the log to the base 2 of x graph there and the other one. So, log to the base 2 of x, when x is, what? 1/4, what were our values? -2. When x is 1/2, 2 to the power of -1 is 1/2, 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4. We know our domain, it was, no it wasn't, it was x greater than 0, wasn't it? The range, x greater than 0, or real y. And we had that the y-axis was a vertical asymptote. And we know that as x approaches 0 from above, y approaches negative infinity. That is our first graph. Y equals log to the base 2 of x. Now, when you want to sketch the next one, or draw up its table of values, all you do is you take these values, and what do you do to them? Add 3. So it's that curve. So the green curve is log to the base 2 of x. But y equals 3 plus log to the base 2 of x is just that curve shifted up 3 units. So off you go. And then I want the points graphed, you know, little circles on the curve where they are. So a quarter, we've got negative 2 plus 3 is positive 1. Negative 1 plus 3, and keep going. What do you get for the next one? 0 plus 3. 1 plus 3 is 4, and 2 plus 3 is 5. Okay, domain. Anything changed? So let's plot those first. We've got a quarter, 1. A half, 2. 1, 3, 2, 4. I want to see the points on the curve like you are sketching it. Y equals 3 plus log to the base 2 of x, or you can write it as log to the base 2 of x plus 3. Just put in your domain range and how it's shifted. And can you also sketch y equals log to the base 2 of x minus 1 while you're there in another color, maybe blue? All right, let's go. So fill it in. It didn't change, neither did the range, vertical axis, because it's only shifted up and down. So nothing's really there's going to be no shifts to the asymptote. And it's the graph of y equals log to the base 2 of x shifted 3 units up. If you can now sketch y equals log to the base 2 of x minus 1, please. Okay. Base 2 of x minus 1. I'm actually just going to, it's the log to the base 2 of x curve, move down 1 unit. I'm just going to move each point down. So from here, move down 1. From here, move down 1. Okay. I might even put this one. Move that one down 1. So here, move down 1, and here, move down 1. So I can do the table of values in a minute. All right. So if you just want to look at each point on the green curve, which is log to the base 2 of x, and move it down 1 unit. So this is y equals log to the base 2 of x minus 1. Everything's just shifted down 1 unit. You can just do that from the original curve. You don't have to draw up a table of values each time. All right. You would know what the original curve looks like, and then just move the points down, or move the points up 3. Or on the page before, move the points sideways. You don't do a table of values every single time. Okay? So we just move these down 1 from where they were before. Okay? All good. All right? So this is y equals log to the base 2 of x shifted 1 unit down. All good? All right. It just reinforces your transformations. Now got log to the base 2 of x and log to the base 2 of negative x. So these values, as before, that was negative 2, 2 to the negative 1 is a half, 2 to the 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4. You can plot them here, 1, 0, 2, 1, 4, 2. Log to the base 2 of x. Now, if looking at the other one, negative, negative a quarter is log to the base 2 of positive a quarter, and the answer for that is, the answer for that one is negative 2. Is that what you're getting? Yep. Log to the base 2, negative of negative a half makes it positive a half. It's the answer you got for positive a half. Negative, negative 1 is positive 1. It's the answer you got for 1. Negative, negative 2 would be the answer you got for positive 2. And negative, negative 4 is positive 4. It's that. So you might want to plot those points. Negative a quarter, negative 2. Negative a half, negative 1. Negative 1, 0. Negative 2, 1. And negative 4, 2. So this is log to the base 2 of negative x. So you can't see that very well. I'll do it in pink. Log to the base 2 of negative x. Okay, so this is the graph of y equals log to the base 2 of x reflected in the, which axis? Yeah, in the y-axis. Very good. So, see, if you're reflecting in the y-axis, on the other side of the y-axis, you've got the negative x values. That's when whatever was positive is now the negative. Okay? Now, we're reflecting with the orange graph down there, we're reflecting another way. So let's look here. We've got log to the base 2 of x. That's the blue graph over there. Got it? And so these are swapped, aren't they? So you might want to go, that's that one. You know what I mean? Otherwise you're going to think the one underneath it is it. This is that one, isn't it? Be careful. All right? Now looking down here, are we good? Let's look at these two. Oh, okay. Look at negative log to the base 2 of x. It's going to be log to the base 2 of x values with just a negative in front of them. So ignore the negative at the moment. Just ignore the negative. Put your finger over it. Let's start here. Log to the base 2 of 2 is 4, but you get negative. So our answer here is, so when x is 4, 2 squared is 4, but you've got to put a negative in front of it because it's the negative of that. So what's the y value? It would have been 2, but y equals the negative of that answer. All right? Or what you do, you look here, you look at all these values, and you just put negatives in front of them. Yes? Yes. All right, so it's just been reflected in which axis? All right, so just be very careful. It is reflected in the x-axis. So when you've got here, you've got negative 2. Here you've got negative 1, 0. Instead of negative 1, we've got positive 1, sorry. And instead of getting negative 2 here, we've got positive 2. So which graph is it, the orange or the purple? It's the purple graph. Look, what I might get you to do over here, because it's a bit hard to tell now, it's all getting confusing. Can you sketch? So if you're going to label this one, so let's just plot our points. When you've got a quarter, it's 2, a half is 1, 1, 0, 2, negative 1, and 4, negative 2. This one is y equals negative log to the base 2 of x. Please, in pencil or red or something else, can you put log to the base 2 of x on the same graph? So log to the base 2 of x, that's there. When x is 2, y is 1. But can you just dot it in? So this is log to the base 2 of x. Can you just do it dotted so that you can see? So the dotted one is y equals log to the base 2 of x. Yeah, can you see it, Just? I'll reduce the brightness. So y equals log to the base 2 of x is dotted. Y equals negative log to the base 2 of x is in purple. It just shows you the reflection. So that is that one. So it's the graph of y equals log to the base 2 of x reflected in the x-axis. Now, the other one, sorry, I should have got these the other way around. Doesn't matter. Very late at night. And the other one. So what's happened to this one? it's log to the base 2 of negative x, which means it's reflected in the y-axis, and then the negative, it's reflected, then that has been reflected in the x-axis. Because you've got the negative there, which flips it down, but this negative x here flips it sideways. So if the original curve is the pencil curve, right? The original curve is the pencil curve. Y equals log to the base 2 of x. If you flip that downwards, which we've got here, and then flip it sideways, you've got the orange curve. Okay? You got that? So this one, so y equal, so this graph here is the graph of y equals log to the base 2 of x reflected in the x-axis and then the y-axis. And it doesn't matter if you do y first and then x first and then y. Okay. Okay, so you can put those points into your table of values. So if you look at, I'd compare it to the one above it. So whatever you've got in the graph above it here, you're going to put a negative in front of those answers. Okay, so you've got 2, where are we? 2, 1, 0, negative 1 and negative 2. And you can have a look there. So negative a quarter is 2, negative a half is 1, negative 1, 0, and so on. So this is the double reflection. Y equals log to the base 2 of negative x. So it's been reflected twice. Okay, but you really need to have that other one there to see what's happened. This one was reflected downwards, and then this was reflected across to get the other one. Okay.